Hey guys, today we lean into a strange kawaii kind of quiet. The night sky is alive with motion. Jupiter burning bright in the east. Mars a small reddish ember. The Milky Way stretching like a ghostly river overhead. And yet, even as one of the most unusual visitors in decades races past, the world's most powerful space agency barely whispers a word. It feels like the universe is trying to call our attention, and the silence on Earth is louder than the stars themselves. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And maybe leave a comment. Tell me where you are, what time it is, and what the night sky looks like from your window tonight. Wherever you are, let the world slow down for a while. Soften your gaze. Let the hum of life around you fade, and gently drift with us into tonight's quiet exploration. Out there, an object named 3IATLAS is streaking across the solar system. It's the third confirmed interstellar object we've ever seen. After Oumuamua in 2017 and Borisov in 2019. Its orbit is not bound to the Sun. Instead, it's a hyperbolic trajectory, meaning it came from the vast dark between the stars, and after a brief hello, it will vanish back into interstellar space forever. Astronomers know this. The data is clear, but what they can't quite explain is the silence. NASA, usually quick to frame discoveries for the public, has kept its language to a bare minimum. A press note here, a short statement there, repeating the same facts: its speed, its brightness, its approach to Mars, without deeper commentary. Compare that to the storm of conferences and detailed breakdowns when Oumuamua was found. Then, the agency's scientists debated shapes and trajectories, whether it was a comet or something more exotic. Now, with 3IATLAS, the tone is subdued, almost hesitant. Is it because they've learned a lesson from the frenzy of 2017? Or is there something in the data they prefer not to say out loud yet? Amateur astronomers have filled the gap. Telescopes from Chile, Hawaii, and backyards across the world stream raw images online. In some of them, the comet's coma, the cloud of gas and dust boiling away, looks ordinary. In others, faint outbursts shoot sunward in plumes, like jets from an engine. Data shows unexpected spikes in brightness, sometimes fading within hours. These are real, recorded by multiple observers. And yet, the official channels rarely acknowledge them. To be clear, silence in science is not always sinister. Sometimes, it's just the careful pause before certainty. Astronomers hate to speculate without solid ground, because every wild guess risks eroding public trust. But still, the contrast between the buzzing night sky and the measured hush of NASA makes people wonder. Even more curious, the timing is uncanny. September 2025 has already been filled with cosmic fireworks, distant gamma-ray bursts, sudden solar storms, and flares that ripple through space weather forecasts. Into this backdrop, a new interstellar comet rushes past, its activity shifting almost daily. Normally, NASA would use such a moment to educate, to inspire, to place humanity in context. Instead, reporters find themselves quoting 2 or 3 identical sentences, recycled from press releases, repeated in different outlets. If you listen closely, you can almost feel the weight of what's unsaid. Not a cover-up, perhaps, but a caution that borders on secrecy. It reminds me of moments in history when space agencies have hesitated before revealing details. Unusual satellite events during the Cold War, or delayed images of the Shoemaker-Levy impact on Jupiter. Not because the data wasn't real, but because interpretation was fragile, politically sensitive, or uncertain. For now, the comet sails on, and so do we, carried by curiosity. You picture it, a pale object in the sky, faint but fast, carrying stories from a star system we may never visit. Each night it grows closer. Each morning its light fades back into dawn, and somewhere in a quiet office or a locked database, there may be information waiting to surface. That's the strangeness of this silence. It's not just about what NASA says, it's about what it doesn't. And as you settle deeper into your pillow, let that thought drift with you. A world-class agency surrounded by telescopes, knowledge, and satellites, and yet a pause, a hush, a measured refusal to say too much. In that gap between data and disclosure lies tonight's mystery. From Earth's perspective, 3IATLAS drifts slowly across the constellations, just another faint smudge of light against the velvet sky. But the mathematics of its orbit tells a far stranger story. Unlike the graceful ellipses that keep planets tethered to the sun, or the long stretched ovals that bind comets for millennia, this trajectory is different. It's hyperbolic, an open curve, a path that enters and exits the solar system only once. It's the unmistakable signature of a visitor, not a native. Astronomers plotted its motion night after night. Using parallax, radar echoes, and the shifting background of stars, they measured its speed, nearly 33 kilometers per second relative to the Sun. That's too fast for any object born here. No gravitational slingshot from Jupiter or Saturn could fling it outward at such a pace. It had to come from outside, from interstellar space. Think about that for a moment. For billions of years, chunks of ice and rock have wandered between the stars. Most never cross our path, lost in the gulf of the galaxy. But every so often, one drifts into our cosmic neighborhood. We call these interstellar objects, or ISOs. They are survivors from other solar systems, bits of planets that never formed, leftovers from disks of dust around alien stars. Each one carries the fingerprints of a place we may never see. When Oumuamua appeared in 2017, its hyperbolic orbit startled scientists. That strange object moved too fast, tumbled oddly, and showed no clear signs of gas or dust. It was the first clue that interstellar debris does visit us, though rarely. Borisov followed in 2019, more like a normal comet, shedding gas and dust. Now, 3IATLAS continues the pattern, proving it's not a fluke. The galaxy sends wanderers, and we are only beginning to notice. Yet, in its path lies something remarkable. Calculations show that 3IATLAS has spent millions, maybe billions of years adrift. Its orbit traces back not to a particular star, but to a region of space between constellations Lyra and Hercules. It could have been nudged loose by the birth of a star system long ago. or by a gravitational encounter in some cluster we'll never map. Imagine that, a frozen traveler carrying whispers of chemistry older than Earth itself. But here's where it gets interesting. Hyperbolic orbits are rare in our observations. Most comets, even long-period ones like Hale-Bopp, are bound by the sun's pull. So, whenever astronomers confirm one, it triggers a flood of questions. How many of these objects pass through unnoticed? Are our telescopes just now sensitive enough to catch them? And if so, why does NASA, an agency that loves to frame discoveries as milestones, say so little? Amateur skywatchers track the numbers with excitement. They share charts showing the comet's steep angle relative to the solar system plane. Some highlight how it swoops near Mars in October before curving outward again. Others speculate about gravitational perturbations. What star or encounter sent it our way? These are open, lively discussions. But from the official channels, the commentary remains muted, as if the path itself were not extraordinary. Of course, there's no denying the science. Orbital mechanics is as reliable as sunrise. If you calculate the eccentricity, the measure of how stretched an orbit is, 3IATLAS scores above 1. That's the hallmark of hyperbola. For planets and comets born here, the number is always below 1. That single digit is enough to prove its foreign origin. It is interstellar. It doesn't belong to us. In some ways, silence makes sense. Once the orbit is measured, the conclusion is obvious. It's from elsewhere. No drama needed. But human imagination fills the gaps. When a thing has drifted between stars for longer than human history, when its orbit alone shouts outsider, it's hard not to ask more. Where exactly did it come from? What secrets of chemistry or structure does it carry? Could it, in some wild scenario, even be artificial? The orbit is both map and mystery. A line drawn across star charts that proves connection with the wider galaxy, and a reminder that the universe does not knock before it enters. We only glimpse, record, and wonder. For now, the visitor's path is certain into our system, around the sun, then gone forever. But the silence surrounding it lingers, like an echo in the dark. When astronomers look at 3IATLAS, they cannot help but think back to 2017, when another interstellar visitor passed silently through the inner solar system. That one was Oumuamua, the first of its kind ever detected. The memory still lingers in the scientific community, partly because of what was said, but perhaps more importantly, because of what was never resolved. Oumuamua appeared in October 2017 as a faint, fast-moving dot. Initial images revealed something elongated, perhaps cigar-shaped, perhaps pancake-flat, depending on how you interpreted the light. What startled researchers most was its lack of a coma. It had no visible gas or dust like a comet, yet its trajectory shifted as if something were gently pushing it. The best explanation was that it released invisible gases, perhaps hydrogen or carbon monoxide, that gave it a small boost. But the data never fully fit the models. The mystery was left open. Some scientists, including Avi Loeb at Harvard, went further. They suggested it might not be a natural object at all. Perhaps it was debris from alien technology, like a shattered solar sail drifting between stars. Others dismissed this as speculation gone too far. But the fact that such a debate could take root shows how thin the evidence was. Oumuamua's brief visit left us with more questions than answers. Now, with 3IATLAS, the comparisons are inevitable. Like Oumuamua, its orbit is hyperbolic. Like Oumuamua, it comes from deep interstellar space. But unlike that first visitor, 3IATLAS does display a coma, a faint tail of gas and dust that makes it look more like a comet. To some, that makes it ordinary. To others, the differences raise suspicions. Could it be masking the same kind of odd acceleration under the cover of a cloud? The echoes go beyond science. Back in 2017, NASA and the European Space Agency were quick to highlight Oumuamua's uniqueness. Press releases spoke of a historic discovery and a messenger from afar. Telescopes scrambled to observe it, from Hubble to ground-based observatories across the globe. Even with its brief visibility, it captured headlines worldwide. But for all that noise, the conclusion was never satisfying. We never photographed it up close. We never measured its composition directly. It slipped away before instruments could settle the debate. This time, one might expect NASA to lean into the drama again. Another chance, another interstellar gift. And yet, the tone is restrained, even quiet. When reporters ask for comparisons to Oumuamua, they receive cautious phrases about differences in activity and further studies needed. The language feels almost designed to avoid stirring speculation, as though the ghost of 2017 still hangs over the conversation. And that's what makes the silence suspicious. If the first interstellar object was treated with excitement bordering on wonder, why does the third, equally rare, equally historic, receive so little emphasis? Perhaps the agencies fear repeating the chaos of speculation that followed Oumuamua. Perhaps they do not want to be drawn again into debates about alien probes or artificial sails. Or perhaps they have noticed something unusual already and are waiting until it can be explained away more safely. It's a reminder that science is not just about numbers. It's about narratives. Oumuamua became a story, one that reached far beyond astronomy journals into the public imagination. 3IATLAS could be the same, but NASA seems determined to keep the story smaller, quieter. That in itself is a choice, and choices always reveal something. For those who remember 2017, the parallels are haunting. An object from another star system, uncertainty about its behavior. A burst of public curiosity met with hesitation from officials. A silence that echoes across years. And now, as the comet drifts closer to Mars, those echoes sound louder than ever. The line between a comet and a mystery is thinner than it seems. For most people, a comet is simple. A ball of ice and dust that melts under the sun, sprouting a glowing tail like a lantern in the dark. But with 3IATLAS, things refuse to stay simple. Amateur astronomers first noticed the coma forming in early July. At first it was faint, a soft haze barely brighter than the background stars. Then, suddenly, the object flared. For a night or two, it shone nearly twice as bright as predictions, only to fade back again. That behavior is typical of some comets, chunks of ice breaking off, releasing bursts of gas. But the timing felt uncanny. Each flare happened not at random, but in patterns that seemed clustered around the comet's closest approach to the inner solar system. Professional observatories confirmed unusual activity. Spectral analysis showed spikes of carbon dioxide emission, a gas not always seen so strongly in comets. Jets of dust pointed in odd directions, at times nearly sunward, as if the object were venting in ways that defied simple solar heating. One image from Chile showed what looked like a plume shooting ahead of its orbit, rather than trailing behind. To some, it resembled a thruster firing. Of course, there are natural explanations. Comets can be unpredictable. Cavities in the ice can suddenly crack, releasing gas under pressure. Dust jets can align oddly depending on rotation. But when the same features recall the debates of Oumuamua, non-gravitational accelerations, strange orientations, the questions return. Is it just ice, or is there more? NASA's official notes are careful. They mention outgassing events and surface activity, the language of comets. They avoid comparisons to artificial behavior. They emphasize the need for more data. Yet silence about the stranger details only fuels speculation. Independent researchers publish preprints pointing out the unusual jets, the brightness fluctuations, the lack of detailed commentary from major space agencies. The phrase comet or messenger begins to circulate online. It's partly poetic, partly provocative. For centuries, comets were seen as omens, heralds of change. In the 21st century, they are frozen archives of the early solar system. But what if this one is also a messenger in another sense? A carrier of mysteries from another star system? Maybe even of something built, not born? That's a question many scientists avoid, but cannot fully dismiss. History teaches us caution. When comet Shoemaker-Levy 9 struck Jupiter in 1994, its breakup and collision were violent, but perfectly natural. When Comet Swan flared suddenly in 2020, it surprised observers but followed physical rules. Yet 3IATLAS carries the extra layer of being interstellar. It is not just any comet. It is one of the rare few that come from beyond. That context makes every anomaly heavier with meaning. In the absence of clear answers, the mystery deepens. For the public, the idea of a messenger resonates more than outgassing. It suggests intent, story, connection. For scientists, it is a dilemma. How to describe what looks ordinary in one moment and extraordinary in the next? How to speak carefully without igniting the flames of speculation? For now, the object continues to shine faintly, carrying its hazy tail across the night sky. To most, it is simply another comet, one among many. But to those who watch closely, the possibility lingers like a whisper. Perhaps this is not only a comet. Perhaps, in some way, we do not yet understand. It is a messenger. The night sky belongs to everyone, or so we like to think. But whenever an object of unknown origin drifts into our solar system, the line between science and security begins to blur. With 3IATLAS, that blur has become a shadow, one cast not by starlight, but by silence from those who normally speak the loudest. Reports began to circulate in late August. Observatories affiliated with defense networks, radar stations, tracking arrays, even missile warning satellites started pinging the object. These facilities are designed to monitor near-Earth space for threats, not cosmic wanderers. Yet suddenly, 3IATLAS appeared in their logs. Some of that data leaked indirectly through professional channels. Small notes and technical bulletins, whispers from astronomers with colleagues in military research. The message was simple, but striking. This comet, though far from Earth, was being watched closely by systems usually reserved for security. Why would that be? On one level, it's understandable. Any interstellar object passing through the solar system at high speed could, in theory, intersect planetary orbits. Monitoring its trajectory is prudent. On another level, the secrecy is curious. Civilian astronomers publish their observations freely. But military data, with its precision radar readings and infrared tracking, remains locked away. The result is a dual reality. The public sees fuzzy telescope images, while hidden databases may hold exquisite details about size, rotation, and outbursts. This isn't new. In 2017, some of the best tracking of Oumuamua came from systems originally designed to watch for nuclear tests and missile launches. Much of that information was classified, accessible only in fragments. History repeats with 3IATLAS. Rumors suggest that high-resolution radar sweeps have already been done, perhaps revealing structure, but nothing is shared. Instead, all that reaches the public is a muted assurance. The object is under observation. Then came a stranger clue. In early September, activity spiked at facilities like Quantico and Vandenberg, where military exercises suddenly shifted schedules. A surge of closed-door meetings coincided with the comet's latest brightness flare. No official statement linked the two, but timing invites suspicion. The narrative of military shadows was born not from conspiracy theorists, but from observers who simply noted patterns. A cosmic visitor appears. Official science stays quiet, and defense institutions suddenly stir. Of course, the simplest explanation is bureaucracy. Space Command and allied agencies coordinate with NASA to ensure accurate orbital data, especially when the public is watching. Extra attention may reflect nothing more than due diligence, and yet silence amplifies imagination. If radar arrays have mapped the comet's surface, why not share even a single image? If classified sensors detect unusual emissions, why not acknowledge them openly? The silence becomes the story. A comet alone is wondrous but ordinary. A comet trailed by secrecy becomes something else entirely. It evokes an older pattern. Cold War satellites tracking meteors, documents sealed for decades, data released only when the danger of misinterpretation has passed. The shadows of the military suggest not just caution, but control. And so, for those who watch both the skies and the flow of information, a tension emerges. Perhaps the silence is protective, meant to shield the public from confusion until the facts are clear. Or perhaps it hides something deemed too disruptive to say aloud. In either case, it means one thing. The full story of 3IATLAS does not unfold only in observatories. It unfolds in conference rooms, classified reports, and quiet exchanges where science and security meet. Above all, it reminds us that in a world where every streak of light might be a signal, the military never stops watching. And with 3IATLAS, their watch seems heavier than usual. Astronomy has always been a field shaped by two lenses: the open eye of the public and the guarded gaze of institutions. With 3IATLAS, that divide feels sharper than ever. On one side are the amateurs, people with backyard telescopes, university students with small observatories, citizen scientists sharing their captures on social media. On the other side are NASA, ESA, and military-linked networks, holding precise streams of data that rarely leave official channels. Between them lies a widening gap of silence. Scroll through astronomy forums today, and you'll find hundreds of images of 3IATLAS. Some are simple smudges against a background of stars, taken with consumer-grade CCD cameras. Others, from semi-professionals, show faint jets of dust, sometimes curling like wisps of smoke. These observers trade notes freely, comparing brightness estimates, plotting the comet's shifting tail, even speculating about chemical composition based on colors. It's messy, collaborative, and alive with curiosity. Meanwhile, NASA's official updates remain sparse. A single-page note might mention the comet's position, another its expected trajectory past Mars. Beyond that, the flow of detail slows to a trickle. Amateurs ask for spectral readings. None are released. They wonder about radar observations. No comment. They point to unusual flares. Silence. For every line of dry, official text, there are dozens of grassroots posts bubbling with questions the institutions do not answer. Why does this matter? Because astronomy thrives on openness. When Oumuamua was discovered, data was made widely available within days, encouraging teams around the world to contribute. Even if debates grew heated, the openness fueled progress. With 3IATLAS, the perception is different. There's a sense of withholding, as if too much access might spark speculation that agencies want to avoid. This gap has consequences. Amateur astronomers often detect anomalies first. Sudden flares, odd tail angles, changes in brightness. Their reports can be invaluable. But without institutional confirmation, these observations live in limbo, half accepted, half dismissed. It leaves the public caught between trust in official silence and excitement from grassroots voices. The contrast becomes a narrative in itself. There's also the role of private observatories. Universities with access to powerful telescopes like Subaru or Gemini sometimes publish their own findings, though often in technical preprints. These, too, can be opaque, filled with jargon. For the wider audience, the most accessible voices are still the amateurs. YouTube videos of comet tracking, Reddit threads filled with stacked images, Twitter posts showing faint smears of light captioned with awe. It's raw, imperfect, but it's what keeps the story alive. In the background, satellite data likely captures more detail than any ground telescope could. Classified infrared arrays, designed to detect missile launches, can also see comets venting gas. Their sensitivity far exceeds what amateurs can achieve. Yet such information remains locked away, leaving only whispers. What the public sees is partial. What institutions see may be complete. That imbalance feeds suspicion. The phrase public versus private data is less about ownership than about access. Who gets to know? Who gets to interpret? And who decides when silence is better than speculation? For now, the answers tilt heavily toward the closed side. The result? A growing sense that the full truth of 3IATLAS is being filtered, not shared. Still, the amateurs persist. Night after night, they set up telescopes, track the visitor, and publish what they see. They remind us of an older truth. The sky belongs to everyone. No matter how many gates are placed around data, no one can hide the faint glow of a comet drifting through the heavens. October 2025 marks a moment written into the path of 3IATLAS, its close brush with the planet Mars. For weeks, astronomers have calculated this encounter with a mix of precision and anticipation. The interstellar visitor will pass at a distance safe by cosmic standards, millions of kilometers away, but close enough that Mars becomes a stage for the encounter. For the first time, an alien comet from another star system moves near a planet we dream of visiting ourselves. On paper, this is a perfect scientific opportunity. Mars is not just a red dot in the sky. It is a world bristling with satellites. Orbiters like MAVEN, Mars Reconnaissance Orbiter, and the European Trace Gas Orbiter circle the planet constantly, equipped with cameras and sensors. Rovers still roam its surface, their upward-looking eyes capable of glimpsing the comet if conditions align. For planetary science, this is extraordinary. A network of instruments already in place, ready to watch as an interstellar object sweeps past. Yet, curiously, NASA has said little. Press releases mention the flyby only in passing, framed as a curiosity rather than an event. No detailed plans for coordinated observations are public. No live updates are promised. It is as if one of the rarest encounters in astronomy, a foreign body passing close to a world we monitor obsessively, is treated as ordinary. That silence feels almost unnatural. Amateurs, by contrast, are buzzing with speculation. Will the comet's coma expand dramatically as it swings sunward past Mars? Could dust trails interact with the thin Martian atmosphere, creating faint meteor showers? Some have even suggested that orbiters might capture images of debris interacting with the planet's magnetic field, however weak. All of this remains possible, at least in theory. And yet, NASA's voice remains muted. The Mars approach is also symbolic. For decades, Mars has been humanity's frontier, home to our probes, our hopes, our science fiction dreams. Now, an object from beyond the stars drifts into its neighborhood, offering a chance to connect our planetary ambitions with our galactic perspective. The fact that the world's leading space agency seems reluctant to amplify this moment only adds to the mystery. Behind the scenes, coordination surely exists. Instruments on orbiters can be commanded to observe unusual targets, pointing cameras, adjusting filters, scheduling passes. All of this takes planning. But if those plans exist, they are hidden in silence, not shared with the public. Perhaps officials worry about raising expectations. Perhaps the risk of no significant results feels too great. Or perhaps the data is already richer than we know, awaiting careful release months from now. What we do know is this. In early October, Mars and 3IATLAS will share the same patch of cosmic stage. One world we dream of walking on. One traveler we will never reach again. If Mars Orbiters record even a glimpse of interaction, a plume, a trail, a meteor arc across thin skies. It will be historic. If they record nothing, the silence will deepen. Either way, the comet's path reminds us that encounters in the solar system are fleeting, and silence can be just as powerful as speech. For the sky watcher on Earth, Mars will glow faintly in the east, and somewhere near it, invisible to the naked eye, the comet will rush past. Two red wanderers, one planetary, one interstellar, sharing a moment in history. And perhaps in the background, data will flow quietly into files we may not see for years. Every comet carries with it a chemical fingerprint, a record of the place and time it was born. For ordinary comets from our solar system, that fingerprint often tells the story of early planetary formation. Water ice mixed with carbon compounds, sprinkled with dust from the primordial disk. With 3IATLAS, though, the chemistry becomes something more. A message from another star system. A frozen sample of alien origins drifting through our skies. Spectroscopic data has begun to trickle in, though not always through NASA. European and Chilean observatories report spikes in carbon dioxide, CO2 emissions, stronger than expected for an object at its current distance from the Sun. Some measurements also suggest faint signatures of carbon monoxide, CO, and possibly traces of exotic hydrocarbons. To a comet scientist, these gases are clues. CO2 sublimates at higher temperatures than CO, so a surge of carbon dioxide at this stage implies that the comet's surface layers are rich in it, perhaps shaped by conditions different from those of our Kuiper belt or Oort cloud. But the results are not consistent. Some telescopes show strong CO2 lines, while others detect almost none. One team suggested that plumes of gas erupt intermittently, like geysers, creating spikes in emissions that fade quickly. Another theory points to rotation. If the comet spins, vents may face the sun at different times, releasing bursts that instruments catch only in certain windows. It paints a picture of a restless object, not a steady one. The dust tells its own story. Polarimetric studies, analyzing how light scatters through the coma, hint that the grains are unusually fine, perhaps smaller than typical comet dust. Some even suggest a higher fraction of silicates, giving the coma a slightly bluer hue under certain filters. To the untrained eye, it looks like a faint mist. To scientists, it whispers of alien chemistry. These details matter because they help place the comet's birthplace. If the ratios of CO2, CO, and water ice differ from what we see in our solar system, it implies that the disk where 3IATLAS formed had different conditions, colder, hotter, richer in certain compounds. In other words, it's a chemical postcard from another neighborhood in the galaxy. Yet here again, silence complicates the picture. NASA has not released a comprehensive chemical profile. Instead, we hear fragments from scattered teams, occasional confirmations from university labs, or leaks through preprint servers. The most authoritative voices remain subdued. No grand statement about alien chemistry, no bold claims about planetary origins. Just careful phrases. Further study required. Preliminary results. Additional observations pending. That silence feels heavy because chemistry is one of the least speculative sciences. Gas emission lines are not ambiguous. They are sharp, measurable, verifiable. If the data shows unusual chemistry, why not share it openly? Unless, of course, the unusual part is precisely what agencies are wary of. Speculation blooms in the absence of detail. Online forums wonder if the CO2 plumes resemble controlled bursts, like engines. Others muse about organic molecules. Could 3IATLAS carry the building blocks of life from another system? Scientists scoff at the wilder claims, but their restraint only adds fuel to the fire. History reminds us that chemical surprises are not uncommon. When Comet 67P was studied by the Rosetta mission, its surface emitted molecules no one expected, including oxygen. The finding reshaped theories of comet chemistry. If a local comet could be that strange, how much stranger might an interstellar one be? For now, we wait. Instruments scan. Plumes rise and fade. Dust drifts outward in delicate trails. Somewhere in that haze is a truth about another star system, one we may never visit. Whether NASA shares it soon or holds it back, the comet itself speaks in chemistry, and chemistry does not lie. For decades, the Hubble Space Telescope has been our cosmic storyteller. From the birth of galaxies to the delicate tales of comets, Hubble has given humanity images that shape the way we imagine the universe. So when 3IATLAS entered the solar system, many expected Hubble to play its usual role. Sharp images, detailed updates, maybe even a press release filled with colorful data. Yet what we've received so far is almost nothing. A handful of technical notes confirm that Hubble has pointed its mirrors at the comet. Observers have filed scheduling requests. Some even received time to track the interstellar visitor. But where are the images? Normally, even raw frames leak quickly into the public archive, where astronomers and enthusiasts can analyze them. In this case, the trail grows cold. Only a few low-resolution composites have surfaced, showing little more than a blurry core wrapped in haze. The high-definition clarity that Hubble is famous for remains conspicuously absent. This is not how it usually works. When Comet Borisov swept past in 2019, Hubble produced dazzling images within weeks. Greenish comey, detailed jets, carefully measured brightness curves. NASA proudly showcased them in press releases. Even Oumuamua, difficult as it was to capture, had Hubble follow-ups shared widely. So why the hesitation now? One possibility is technical. Hubble is aging, its instruments strained by decades in orbit. Aligning with a faint, fast-moving target like 3IATLAS is challenging. But many astronomers point out that Hubble has tracked dimmer, faster objects before. Another explanation is timing. Perhaps data is being reserved for peer-reviewed papers before public release. That, too, has precedent. Yet the silence, the lack of even preliminary previews, feels deliberate. Adding to the mystery is the James Webb Space Telescope. Webb, with its infrared eyes, should be ideal for studying a dusty, gas-emitting body. And while scientists have hinted at Webb observations, the data remains behind walls of embargo. No press conference, no major announcement, just whispers in academic circles that spectra have been taken, showing intriguing features not yet disclosed. To the public, the result is unsettling. The two most powerful telescopes humanity has ever built, the ones that captured infant galaxies and peered into the atmospheres of exoplanets, are strangely quiet about the most exotic comet in years. If this were just another icy body, why not share the pictures? If the data were ordinary, why not let us see? The silence of Hubble has become symbolic. It suggests not just a technical gap, but a choice to withhold, to delay, to speak softly when the object itself demands attention. Some argue this is caution, scientists avoiding premature claims. Others whisper of suppression, of details too unusual to release without careful framing. Either way, the outcome is the same. A cosmic visitor drifts past, and the telescopes designed to reveal its secrets remain mute. History repeats itself here too. In the 1990s, Hubble's observations of certain unusual gamma-ray bursts were withheld until data could be properly interpreted. The same was true of some asteroid tracking in the early 2000s, when potential impact probabilities were embargoed to prevent panic. Silence, in other words, has precedent. But each time it happens, trust erodes. For now, the Hubble archive sits quiet, the Webb database locked. Amateur astronomers share their pixelated images. Grassroots voices keep the story alive, while the most exquisite data lies hidden in servers and files. The comet shines faintly on, indifferent to human silence, its secrets intact for those with access, and absent for those without. The silence of Hubble is more than an absence of pictures. It is the sound of restraint in a moment that begs for wonder. And for many, that silence feels louder than the comet's glow itself. When silence surrounds an event in science, it often isn't the first time. History is full of moments where data was delayed, softened, or filtered before reaching the public. Looking back, we can see a pattern. Whenever cosmic discoveries seem too uncertain, too alarming, or too disruptive, the flow of information slows. The story of 3IATLAS fits into that long tradition. Take 1989, when NASA tracked a small asteroid that had a non-negligible chance of impacting Earth. For weeks, calculations shifted daily, the risk rising and falling. Instead of making the debate public, details were contained to internal memos until the probabilities fell to near zero. Only afterward did the story emerge. Officials later admitted they feared panic if early numbers were misinterpreted. Or consider 1994, when comet Shoemaker-Levy 9 was discovered on a collision course with Jupiter. At first, some astronomers speculated about Earth impact. Those early calculations were quickly corrected, but public announcements lagged until consensus formed. Even then, the initial descriptions underplayed the drama. Only later did NASA fully lean into the spectacle, broadcasting the impact as it unfolded. More recently, Oumuamua's discovery in 2017 carried its own silences. While scientists spoke freely about its odd trajectory, data from certain tracking networks, especially those tied to military systems, remained inaccessible. Amateur astronomers complained that fragments of information trickled out long after the object had faded from view. By then, debates about its nature had already spiraled into speculation. that still echoes today. These episodes illustrate a recurring theme. Silence is not always about hiding the truth, but about controlling the narrative. Agencies fear that premature disclosure could fuel wild theories, damage credibility, or spark unnecessary fear. But in trying to control speculation, silence often has the opposite effect. It breeds more of it. The very absence of detail becomes a mystery to fill. And now, with 3IATLAS, the parallels grow sharper. Just as in past cases, data exists. Orbital paths, spectral lines, images. Just as before, much of it remains sealed, waiting for official interpretation. And once again, the public watches with a mixture of fascination and frustration, piecing together a story from fragments while suspecting that more lies behind closed doors. Of course, we should be fair. Science is slow by nature. Peer review takes time. Raw data must be calibrated, cleaned, and cross-checked. An image can look extraordinary until you realize it was an artifact of the detector. Agencies know this and hesitate to feed speculation with incomplete evidence. Yet, when the subject is an interstellar visitor, the stakes feel higher. This is not just another comet. It is a message from the galaxy, fleeting and unrepeatable. Every day of silence feels like a lost chance. Patterns in history remind us that this tension is not new. Whenever science intersects with mystery, the urge to control information rises. Sometimes for caution, sometimes for politics, sometimes simply for order. But the pattern also tells us something else. Truth eventually surfaces. The asteroid that never hit Earth. The comet that shattered on Jupiter. The odd trajectories of Oumuamua, all of it became public knowledge in time. So, perhaps the silence of NASA and other agencies around 3IATLAS is not permanent. Perhaps it is just another pause, another careful breath before the story is told. Yet for those watching the skies now, living through the mystery in real time, the echoes of history feel familiar. And those echoes remind us that silence, however well-intentioned, always leaves space for suspicion to grow. Few names stir debate in modern astronomy as much as Avi Loeb. The Harvard astrophysicist has a talent for taking mysteries and amplifying them into bold possibilities. When Oumuamua was discovered in 2017, Loeb suggested it might be alien technology, a fractured light sail drifting between stars, or a probe sent intentionally. The claim set off a storm. Many scientists dismissed it as reckless, but the public was captivated. And now, with 3IATLAS, Loeb's shadow stretches into the conversation once again. So far, Loeb has not published a major paper about 3IATLAS, but his previous work looms large. In interviews, he has hinted that interstellar objects deserve to be treated as potential probes, not just rocks. His argument is simple. If we are sending spacecraft into interstellar space, Voyager, Pioneer, New Horizons, why couldn't another civilization do the same? If one of their relics drifted near us, it might look like a comet or an asteroid until we studied it more closely. That provocation shapes how silence is interpreted. Every time NASA issues a cautious, minimal statement, skeptics ask, are they avoiding another Oumuamua moment? Are they trying to prevent Loeb's ideas from gaining traction again? After all, his book Extraterrestrial sold widely. His media appearances reached millions, and his theories planted a seed in the public imagination that still grows. Once you raise the possibility of a messenger from another civilization, it cannot easily be unspoken. Among scientists, Loeb's views remain controversial. Some argue that speculation about alien probes distracts from serious research. Others admit, reluctantly, that his point is valid. The galaxy is vast, and interstellar debris is an obvious candidate for technological seeding. Even if 99.9% of objects are natural, why assume all of them are? The debates flare quietly in conferences, whispered between cautious slides of data. With 3IATLAS, the ingredients are ripe for another provocation. Hyperbolic orbit? Check. Unusual activity? Check. Military interest? Check. Silence from official agencies? Check. To those who remember 2017, it feels like déjà vu, and if Avi Loeb, or anyone in his camp, decides to step forward with a paper or op-ed, the cycle will ignite again. That possibility may explain some of NASA's restraint. Officials may prefer to starve the speculation before it starts, limiting details until interpretations are ready. The irony is that silence itself gives oxygen to the very theories they wish to avoid. Online forums already link 3IATLAS to Loeb's earlier work, citing the same anomalies: jets that look directional, unexplained surges in brightness, possible non-gravitational forces at play. The conversation has begun, with or without him. Loeb's provocations are not just about aliens. They are about openness. He has often criticized institutions for being too cautious, too afraid of ridicule, too slow to release raw data. In his view, science should explore bold ideas without fear. Even if most are wrong, one could change history. For many, that philosophy resonates. For others, it is reckless. In the end, Avi Loeb stands as a mirror. His presence in the background of 3IATLAS reflects the fault lines in science communication. Between caution and curiosity, between credibility and wonder, between silence and speculation. Whether or not he publishes on this comet, his earlier words echo in the silence. And those echoes may be exactly why NASA seems so careful, so restrained, so quiet. In the modern age, silence rarely stays silent. If official voices grow quiet, the media rushes to fill the void. But with 3IATLAS, what has emerged isn't a flood of bold reporting. It's a vacuum. Headlines repeat the same 3 or 4 lines, often word for word, recycled across dozens of outlets. An interstellar comet passes through the solar system. Scientists observe unusual behavior. NASA says more study is needed. Beyond that, there is little. This sameness is striking because space stories usually thrive on variety. When James Webb revealed its first images, every outlet carried a unique angle. Infant galaxies, glittering star clusters, cosmic cliffs. When asteroids skim past Earth, headlines range from reassurance to sensationalism. But here, with one of the rarest kinds of objects, a visitor from beyond the stars, the coverage feels eerily uniform, restrained, almost scripted. The reason is partly structural. Most outlets rely on press releases. If NASA and ESA issue only a few cautious notes, that's all the journalists have to build on. Few reporters are equipped to analyze orbital mechanics or spectral lines on their own. And so, they repeat what they are given, polishing the language, but not the substance. The result is a media landscape echoing with silence. Meanwhile, independent channels thrive. YouTube astronomers, podcast hosts, and Twitter threads from citizen scientists offer far richer commentary than mainstream outlets. They speculate about the comet's chemical composition, compare its flares to past anomalies, debate Avi Loeb's theories. Some lean into conspiracy, others into careful analysis, but all fill the space left open by institutions. For curious minds, these voices become the only source of depth. The vacuum has consequences. Without authoritative storytelling, public imagination drifts toward extremes. Some see 3IATLAS as proof of alien messengers. Others dismiss it as another rock, unworthy of attention. Between those poles lies the truth, but few authoritative voices remain to guide the conversation. Silence leaves interpretation unmoored. We've seen this before. During the discovery of exoplanets in the 1990s, cautious statements often left journalists scrambling to frame stories. Some declared new Earths, while others buried the news entirely. Only later, when NASA began producing polished narratives, did exoplanet reporting stabilize. With Oumuamua, the opposite happened. Institutions leaned in too far, sparking waves of speculation that never died. Now, with 3IATLAS, the pendulum swings back to underplaying. Neither extreme serves the public well. In a way, the media vacuum mirrors the comet itself. Faint, elusive, visible only to those who look closely. It drifts through headlines without resonance, its presence acknowledged but not explored. For those who hunger for cosmic wonder, the silence feels like a lost opportunity. For those who fear public overreaction, it feels like safety. But in truth, it is a fragile balance, because vacuums never last. Sooner or later, someone fills them. Perhaps that's why speculation thrives online. In the absence of rich coverage, whispers gain power. Leaked data, amateur images, even wild theories become fuel for curiosity. Whether NASA intends it or not, the vacuum they leave has become part of the story. And like any vacuum, it pulls everything toward it. Fact, fiction, and imagination alike. When official channels fall quiet, alternative voices rise to fill the silence. With 3IATLAS, those voices are not just conspiracy theorists in the margins. They include citizen scientists, independent observatories, and even universities willing to share their data before agencies like NASA make a move. Together, they form a patchwork chorus, offering glimpses of the comet's true nature. One of the most striking features of this chorus is its diversity. In Chile, amateur astronomers use backyard telescopes enhanced with digital stacking software to reveal delicate jets streaming from the comet's nucleus. In Eastern Europe, university labs share preprint papers analyzing light curves that show rapid brightness fluctuations. In Japan, a small observatory releases polarimetric data, suggesting fine-grained dust scattering differently from local comets. None of these voices speak with the authority of NASA, but collectively, they paint a picture far richer than the official narrative. Social media has amplified this ecosystem. On Reddit's astronomy forums, threads dissect every new image, some reaching thousands of comments. YouTube hosts Comet Watch live streams where enthusiasts track the interstellar traveler in real time, often pulling in more viewers than mainstream news clips. Twitter, or what's left of it, hosts heated debates between astronomers, skeptics, and enthusiasts, with each side citing their preferred data. The tone ranges from rigorous analysis to poetic wonder. What makes these voices powerful is not just the information, but the passion behind it. Amateurs remind us that astronomy has always thrived on ordinary people looking up. Galileo was not a government employee. The first discoverers of countless comets were backyard observers scanning the skies with small instruments. In that sense, 3IATLAS belongs to everyone, not just institutions. The silence of NASA only reinforces this truth. Universities, too, play a role. Without the same political constraints as agencies, some teams release raw spectra on open archives, allowing independent researchers to analyze chemical ratios themselves. These data sets, while technical, inspire discussions far more nuanced than the sound bites in mainstream media. They show a comet with CO2 outbursts, dust behavior that doesn't fit clean models, and rotational dynamics that remain uncertain. Each anomaly sparks curiosity rather than dismissal. Of course, not all alternative voices are reliable. Some seize the vacuum to push wild theories, claims of alien spacecraft cloaked in dust, predictions of hidden threats to Earth. These grab headlines in fringe corners of the internet, muddying the waters for those seeking clarity. But even here, the pattern is clear. When official silence grows heavy, imagination rushes in to fill the space. The alternative voices matter because they keep the story alive. They ensure that 3IATLAS does not vanish into obscurity while institutions hesitate. They remind us that science is not a monologue but a dialogue, and that sometimes the loudest truths come not from authority, but from persistence. In forums, live streams, and backyard observatories, the interstellar visitor is watched, discussed, and cherished. Perhaps that is fitting. A traveler from another star system should not belong to one agency or one country. Its story is too vast, too cosmic, to be contained by silence. In the hands of alternative voices, it becomes something universal, a reminder that the universe belongs to everyone who looks up and wonders. When faced with the unknown, humanity often walks a tightrope between fear and caution. Atlas is no different. To some, NASA's silence feels like secrecy, a deliberate withholding of truth. To others, it is simply caution, the careful restraint of scientists who know how quickly speculation can spiral. Somewhere between those two poles lies the reality, a balance shaped as much by psychology as by data. Fear has always accompanied comets. In ancient times, they were seen as omens, fiery swords in the heavens heralding disaster. Even today, their sudden appearance can stir unease. An interstellar comet, by definition, carries an added weight. It comes not from the familiar reservoirs of our solar system, but from the depths of another star's domain. That alone sparks primal questions. What if it's dangerous? What if it's a sign of something greater? What if we don't understand it at all? Caution, however, is the language of science. Researchers know that extraordinary claims demand extraordinary evidence. A flare of CO2 may look mysterious, but without multiple confirmations, it could be nothing more than an instrument error or a natural crack in the comet's crust. A plume pointing sunward may seem like an engine firing, but it could simply be rotation. To release such anomalies to the public without full context risks inviting misinterpretation. In a media landscape hungry for drama, restraint can feel safer than openness. Yet the silence does not erase the tension. It magnifies it. When agencies choose not to speak, fear fills the void. Theories of secrecy bloom. Perhaps there's evidence of alien origin, or a military interest too sensitive to reveal. Perhaps the chemical profile contains something shocking. Perhaps the object's behavior defies models. None of this may be true, but absence of information allows imagination to grow unchecked. Between fear and caution lies trust. When scientists withhold data for peer review, they ask the public to trust that the eventual release will be clear and accurate. But trust has been strained in recent years, from shifting narratives about space missions to delays in publishing raw telescope results. With 3IATLAS, every day of silence chips at that trust, turning cautious restraint into perceived secrecy. It is a delicate balance. Too much openness risks confusion and ridicule. Too much silence risks suspicion and conspiracy. NASA, like all scientific institutions, walks that line carefully. But the comet itself does not wait. It continues its journey, shedding dust and gas, offering its mysteries in real time. And in the gap between what we see and what we are told, humanity negotiates its own emotions. Fear of what we don't know, caution in how we interpret, and the fragile hope that truth will emerge. Ultimately, 3IATLAS reminds us that our response to the unknown is as revealing as the object itself. The comet shows us not only chemistry and motion, but the way we handle uncertainty, with silence, with speculation, with a dance between fear and caution. And in that dance, the mystery grows stronger still. At some point, the comet itself fades into the background, and what remains is the question of how humanity responds to the unknown. 3IATLAS is not just a frozen body drifting through our solar system. It is a mirror, reflecting the ways we handle wonder, doubt, and trust. Its journey is fleeting, but the silence surrounding it lingers, forcing us to look inward as much as outward. The broader question is this: what does silence from an institution like NASA mean? For some, it is evidence of secrecy, a suspicion that truth is being withheld. For others, it is simply the patience of science, the pause before announcing conclusions that might later be overturned. Both interpretations reveal more about us than about the comet itself. We project our hopes and fears onto that silence. Trust is the core issue. Science relies on it. Trust that data is accurate, that interpretations are honest, that institutions serve the public interest. When updates feel filtered or delayed, that trust erodes. Each fragment of withheld data becomes fuel for speculation. Each absent image an invitation for rumor. The silence grows louder than the facts. And yet, perhaps the truth is less dramatic. Perhaps 3IATLAS is simply another comet, fascinating but not revolutionary. Perhaps NASA's silence is just bureaucracy, not conspiracy. But even if that is the case, the way we respond to it, our hunger for answers, our frustration at the gaps, our instinct to imagine more, says something essential about humanity. We are storytellers at heart. We seek patterns in the stars, even when none are offered. The comet reminds us, too, of scale. For billions of years, objects like it have drifted unseen between the stars. We have only just begun to notice them. Each one is rare, precious, a sample of another world delivered free of charge by the galaxy. How we choose to engage with them, whether with openness, secrecy, or speculation, shapes not only our science, but our sense of ourselves as explorers. In the end, the silence of NASA may not matter as much as the questions it stirs. Questions about trust, about transparency, about the thin line between caution and concealment. Questions about what it means to share discovery in an age of instant media and restless imagination. Questions that reach beyond one comet to the very heart of how we, as a species, face the unknown. And so the broader question remains, whispered not only by the comet, but by the quiet between official words. How do we want to know our universe? Through filtered voices or through open wonder? Through silence or through shared discovery? The answer, perhaps, will shape not only how we see 3IATLAS, but how we greet every visitor the galaxy sends our way. And now, as the comet drifts further into the dark, our story slows. The rush of speculation, the whispers of secrecy, the tug of war between fear and caution, all of it fades into the quiet rhythm of the stars. The Atlas continues its path, indifferent to our questions, indifferent to our silence. It will leave the solar system soon, carrying its secrets back into the interstellar night, never to return. For us, what lingers is not just the science, but the feeling. The hush that NASA leaves, the murmur of amateurs filling the gap, the memory of earlier mysteries like Oumuamua, all of these remind us that discovery is not a straight line. Sometimes it is a tangle of voices. Sometimes it is silence that speaks the loudest. Wherever you are tonight, let yourself rest in that thought. The universe is vast. Its stories larger than our institutions, larger even than our fears. Every visitor, every comet, every star, every whisper of cosmic radiation is a reminder that we are part of something bigger, something ancient, something still unfolding. So breathe deeply. Let the weight of unanswered questions drift away. Let the silence become not suspicion, but serenity. In the stillness of the night, with the stars above and the hum of your own thoughts around you, remember that not every mystery needs an immediate answer. Some can simply be held gently, like a stone warmed in the hand, carried with you into dreams. And as you close your eyes, let 3IATLAS sail on in your imagination. A messenger, a mystery, or simply a comet, vanishing into the eternal dark. Sweet dreams, fellow traveler.